At 400 kilometers per hour, each tire on the Bugatti Chiron bears more force than the weight of a small car. 4 turbochargers create so much heat, 10 radiators and 60,000 liters of air per minute barely keep the engine alive. 1,500 horsepower, nearly 2 tons, road legal. Yet the Chiron's greatest achievement may have nothing to do with speed, and that story begins with an impossible brief. In February 2011, Wolfgang Durheimer took the helm of Bugatti with a mandate that defied automotive reality. The Veyron had already pushed engineering to its absolute limits, conquering the 400 kilometers per hour barrier. Yet Durheimer demanded something far more radical than a mere successor. The next car had to deliver more power, higher top speeds, and total high-speed stability, while simultaneously increasing refinement and handcrafted luxury. The engineering team rejected the idea of a temperamental, stripped-out track toy. This machine had to remain entirely road legal and usable on ordinary streets, behaving as a civilized grand tourer on daily commutes. This intense dual requirement created an unprecedented engineering paradox, forcing a heavy car to balance the extreme physics of near flight with everyday reliability. To turn this impossible brief into a production reality, Bugatti's design team had to reject standard mechanical layouts, starting with an engine configuration so ambitious it would rewrite history. Gregor Gries and his engineering team answered this challenge by redesigning Bugatti's power unit, creating an 8-liter quad turbocharged W16 engine. Rather than a traditional V-shape, this design links 2 narrow-angle, 8-cylinder blocks to a single crankshaft, forming a tight W configuration. This compact layout produces a verified 1,500 PS, or 1,479 horsepower. But power figures only describe part of the experience. The engine generates 1,600 Newton-meters, or 1,180 pound-feet of torque, at just 2,000 revolutions per minute. On the asphalt, this low-end force translates to a direct, physical punch that pins passengers into their seats the instant the driver presses the pedal. To keep this massive output manageable and responsive, Gries used a clever sequential turbocharging setup. 4 turbochargers work in distinct stages. 2 smaller turbos spin up instantly from idle to eliminate lag, while the remaining pair activates as the tachometer climbs past 3,800 revolutions per minute. This creates a smooth, continuous wave of acceleration that mimics a jet engine. Yet generating this extreme energy also releases a massive thermal wave, creating a heat burden that threatened to melt the entire vehicle from the inside out. A network of 10 radiators forms the silent backbone of the Chiron, managing a thermal load that would otherwise melt the vehicle. This architecture uses split coolant circuits to lower temperatures in the engine, the transmission, the turbochargers, and the active Aerodynamics hydraulic systems all at once. High-flow pumps push about 800 liters of coolant per minute through the primary loop, while body channels direct more than 60,000 liters of air through the engine bay every minute. To optimize charge air cooling, engineers increased the intercooler surface area by 20%, ensuring the intake air remains dense and cold. This massive cooling system proves that sustained hypercar performance is ultimately a battle against heat. But as velocity builds toward the vehicle's limit, a second, equally dangerous challenge begins: keeping the heavy chassis from taking flight. At high velocities, the Chiron's exterior ceases to be mere bodywork and becomes an active control system. Above 250 kilometers per hour, the hydraulic rear wing rises into the slipstream. Generating up to 800 newtons of downforce, this wing constantly adjusts its angle based on the chosen driving mode, balancing stability against drag. When the driver stomps on the brakes, the wing tilts forward instantly, acting as an air brake to assist the carbon ceramic discs. If you like this kind of video, please subscribe to the channel and leave a like. It really helps us create more documentaries like this. And now, let's return to the question everyone wants answered. How fast could the Chiron actually go? The standard Chiron delivers numbers that redefine straight-line acceleration. From a standstill, it strikes 100 kilometers per hour in 2.4 seconds. It passes 206.5 and crosses 313.6 seconds. If given enough open asphalt, it keeps pulling until an electronic limiter halts the momentum at 420 kilometers per hour. The Chiron Super Sport 300 Plus operates in another category. This version uses a different 1600 PS configuration, raising the electronic limiter to 440 kilometers per hour for production cars. Then there is the famous 490.48 kilometers per hour run. This run did not come from a standard showroom example. It required a specially prepared pre-production car built with an extended rear body to stabilize high-speed aerodynamics and reduce drag by 5%. To survive the run, Michelin created bespoke single-use tires reinforced with carbon fiber, designed to withstand over 1,500 kilograms of lateral force. At these extreme velocities, centrifugal physics subject the tires to incredible stress, threatening to pull the rubber apart under immense rotational weight. This speed run was a highly controlled full-system engineering test rather than a simple horsepower stunt. The team required flawless track conditions at Aerodynamics, precise wind speeds, and rigorous safety protocols. Ultimately, conquering extreme velocity requires total vehicle preparation, going far past basic engine output. Inside the quiet, sterile atelier in Molsheim, France, the raw violence of the test track fades into whisper-quiet precision. Here, Bugatti hand-assembles each Chiron in a process requiring up to 400 hours of exacting human labor. Under the guidance of design director Achim Anscheit, the hypercar is treated less like a mechanical assembly and more like an haute couture sculpture, balancing brutal performance with uncompromising artistry. Artisans spend over 40 hours hand-stitching full-grain leather interiors, sculpting a cabin that isolates passengers from the extreme forces outside. This level of personalization reflects the car's extreme exclusivity, with production strictly limited to just 500 units worldwide. Each carried an original base price of approximately 2.9 million euros. The name itself honors Louis Chiron, the legendary Monegasque racing driver who dominated Grand Prix tracks for Bugatti in the 1920s and the 30s. It is a nod to heritage, but once the final hand-polished lacquer dries, these 500 bespoke creations transition from engineering triumphs into the hands of a select few collectors, where the reality of ownership brings its own staggering demands. Owning a Chiron requires managing a highly specialized machine. The physical reality of operating at this level begins with a strict maintenance schedule. Bugatti mandates a full service every 10,000 kilometers or 12 months, with a standard annual checkup costing approximately 30,000 euros. For deeper technical interventions, such as inspecting the carbon fiber monocoque and disassembling the complex mechanical systems, a major overhaul can quickly exceed 100,000 euros. Even the basic consumables carry extraordinary demands. A fresh set of Michelin tires, engineered specifically to handle the massive load and high rotational forces, costs around 25,000 euros. Fuel consumption also reaches punishing levels when the vehicle is driven near its limits. While exact figures depend on driving style and aerodynamic drag, running the W16 engine at its maximum velocity will drain the entire 100-liter fuel tank in approximately 9 minutes. These operational costs are not arbitrary luxury markups. They are the direct mathematical consequence of operating at the absolute boundary of road-going physics. Today, the automotive world stands at a historic crossroads. As electricity redefines performance, this machine remains a monument to mechanical ambition. It is the peak of an era we will never see again. Subscribe for more deep engineering stories.